Hello students and welcome back to this channel. So in this video we are going to be starting quadratic equations. Now quadratic equations is going to be a full topic that is going to be ended in two videos and it's under pure mathematics. So this video is presented to you by Algembe Yusuf. You advise share it to your colleagues so that we can all learn as a team. Now this is going to be our third topic. The first topic we are looking at numerical concepts which involved surds indices, though the logarithm video is not yet uploaded. So it's also going to be uploaded handling logarithms and seeing how we can solve the numbers under that topic. So in this video we are going to be starting quadratic equations. So quadratic equations are quite diverse. So we have decided to divide the topic into two videos. So this is going to be the first video introducing you to the basic concepts under quadratic equations and how we can solve the quadratic formulas. Now, like I said before, here we are providing you with data to help you learn how you are going to simplify the scenarios that you are going to be presented with in the assessments or in the examinations. At the end of it all, we shall provide scenarios or items to be attempted so that you can use the data you have learned here in interpreting and solving the mathematical items that will be brought to you. Now starting, we are saying that a quadratic equation is going to be an equation which is in the form of ax squared plus bx plus c to be equal to 0. But for this, a must not be equal to 0. So it's going to be called a quadratic equation. Now we're also saying that there are going to be three types of the quadratic equation, and one type we are going to look at where we are having a constant having a coefficient of x squared and the other constant without a coefficient of x being equal to 0. For example, let's solve some of the following equations. So if at all you're having x squared minus 16 being equal to 0, how can you solve, or how can you best solve that? And if at all you're having x squared minus 24 being equal to 0, how can you best solve that? So if at all you're having only one constant in your quadratic equation, we make the constant the subject. So looking at the solution for part A, if you take negative 16 beyond the equal sign, it's going to become a positive. So you're going to remain with x squared being equal to 16. Now you're going to find square root on both sides. But now here, remember, when you're finding square root at a level, we expect your answer to be either positive or negative. So that's why you're seeing this positive or negative sign. So whenever you're finding square root, you should give your answer in terms of two options, that x is going to be equal to positive or negative 4. And the reason for that is because when you're having x squared, we expect that there are two unknowns of x. So if at all there are two unknowns of x, that's why you have x times x to give you x squared. That's how that quadratic equation was got. So if at all there are two unknowns of x, when you're getting the square root, we expect you to get two possible alternatives, and that's going to be positive or minus the answer value you have got. Now you're going to implement the same idea in part B simply by making, now part B in the question we missed here 2, so you make sure that you put a 2 as a coefficient of x squared. So you make the value containing the constant, or the x value containing the constant, the subject by simply taking 24 across the equal sign, and then you're going to remain with 2x squared to be equal to 24. So after here we divide through both sides by 2 and then remain with x squared to be equal to positive 6. Then from there we find the square root. Like I said, when you're finding square root, the answer you must get must be either positive or negative. So that's why whenever you see me getting a square root, my answer is positive or negative plus the answer value. Now in pure mathematics, the actual answer or your final answer must be to a minimum of 4 decimal places, and you need to pay very close attention to that. Your minimum value of decimal places in pure mathematics must be 4 decimal places, and the same applies to applied mathematics. Now when you go to solving other quadratic equations, for example here you can see that we are having x squared and you're also having another constant on x. Now, some of you here might have interpreted this. You may take -7 this side, and then you cross away x. But here you need to know that we don't cross unknowns in pure mathematics. So what you do instead, looking at the solution, you classify or you prefactorize out the common unknown across or over those two common terms. So if you look at part A, since x is common on x squared and also -7x, we prime factorize it out. Now after prime factorizing it out, you're going to remain with x into bracket of x minus 7. Now here, that means that you're left with solving either x to be equal to 0 or x minus 7 to be equal to 0. So that's why you're seeing that, implying that x is equal to 0 or x minus 7 is equal to 0. And if you make x the subject here by taking -7 this side, you're going to end up with two values of x. So either x is going to be equal to 0 or x is going to be equal to +7. And therefore the solutions are going to be x being 0 and x being equal to +7. Now you can first pause the video and you try out part B before you proceed to the next part, or before I show you the solution of it using this idea on solution A. Now looking at that solution, still we say that when you're having two constants on a value and there is no any other figure, we prime factorize out that common constant, but we do not cross or divide it. We do not divide by unknowns. So after prime factorizing, on our part B, you're going to remain with x into 3x plus 5. We prime factorize out x because it's common on the two figures. We had 3x squared plus 5x. So since it's common, we prime factorize out the common unknown and remain with x bracket of 3x plus 5 being equal to 0. So here you are left with two options, either x is equal to 0 or this bracket is equal to 0. So if you make x the subject, from this we take 5 this side, it becomes -5, and then you divide through by 3, you remain with x being equal to -5 over 3. And therefore the solutions are going to be either x is equal to 0 or x is equal to -5 over 3. Now let's look at type 3 equations where you're having two values or two constants with coefficients of x, one of them being x squared, the other one being x, and the other one being a constant without any coefficient of x, and our equation must be equal to 0. So here we are going to solve it using different methods. So basically we are going to look at factorization method, bulldozer method together with completing squares. Now let's start with the factorization method. Standard factorization method, we are going to look at these examples. So part A, we are going to be solving x squared plus 5x plus 6 to be equal to 0. Then part B, 2x squared minus 13x plus minus 24 to be equal to 0. Then C, like that, and then D and E subsequently. Now remember that in the previous video, I told you that if you're having fractions, the first thing to do is to get the LCM and multiply throughout, and you make your equation linear. So the same concept you are going to be using here. But here specifically, we are aiming at getting a quadratic equation. Now let's look at the solutions under that. Now with the case of the factorization method is where you put the quadratic equation into your calculator. If you put the first equation into your calculator, you're going to get two values of x, either x is equal to -2 or x is equal to -3. But when you're using the factorization method, you reverse the symbols and then you reverse the signs on those values and then you add it to x. So if I tell you got -2 in your calculator, the first factor you're going to have is going to be x plus 2 because you just reverse the symbol. So instead of -2, you write +2. And the other one, since we got -3, the other factor is going to be x plus 3. Instead of -3, we write +3. So you get the two factors by multiplying the two brackets of x plus 2 plus x plus 3, which represents the quadratic equation previously. Now there is a common mistake whereby some of you, after getting these two factors, you forget equating it to 0. Now there you are going to miss a bonus mark for that. So it will be B0. If I told you factorize and you forget equating, you factorize the quadratic equation to 0. Now here we are left with two options. Either this bracket is equal to 0 or the other bracket is equal to 0. So if you equate x plus 2 to 0, you're going to get x minus x being equal to negative 2 as your solution. And if you equate x plus 3 to 0, you're going to get x being equal to negative 3 as your solution. And therefore you're going to conclude that therefore the solutions are going to be x being equal to negative 2 and x being equal to negative 3. Now part B, we do the same thing, but for part B, if you put your values in the calculator, that quadratic in the calculator, you're going to get negative 3 over 2, or negative 1.5. So if at all you're having x equals to negative 3 over 2, you may leave it as a fraction by saying that the first bracket is going to be x plus 3 over 2. Or someone may just say, if at all we are to do a side work, let's try to do it up here. If at all you have seen that in the calculator you have got, this is how we get factors, all those brackets. If at all in the calculator you have got the value of x to be equal to negative 3 over 2. So what you do first is to cross multiply. If at all you're having a fraction, so you're going to end up with 2x. You're going to end up with 2x to be equal to negative 3. So what you want to do is to equate our equal sign to a 0. So we are going to take negative 3 this side, and that's when we get our factor. So you're going to end up with 2x plus 3 as the other factor, and this is going to be equal to 0. So this is how you extract your factors when you are having a fraction on your calculator. So that's why the first bracket we are having 2x plus 3, and then the second bracket we are having x minus 8, because on your calculator we had positive 8. So the other factor is going to be x minus 8. You simply reverse the signs and then you equate it to 0. I said majority of you forget to equate this after factorizing to 0 and you miss out marks. So with that, you either equate this bracket to 0 or the other bracket to 0 and you make x the subject. So one is going to be x is equal to negative 3 over 2 and the other one is going to be x to be equal to 8. And therefore the solutions are going to be equal to negative 3 over 2 and x being equal to 8. Now looking at part C, writing our equation is going to be this. Putting all this quadratic equation into your calculator, you're going to get two values of x. One is going to be negative 3 and the other one is going to be positive 5. So to get the factors, we simply reverse this. And this step is crucial. Some of you come from here and then you put the values in your calculator and you get these answers. Now you'll be marked wrong because you have missed vital steps on how you are getting those values. We want to see the steps from which you are getting those values, and this is what we teach under factorization method. So since you are getting negative 3 and positive 5, your factors are going to be x plus 3 and x minus 5. Then with that, either this bracket is equal to 0 or the other bracket is equal to 0. So you're going to end up with the values of x being negative 3 or being positive 5. And then you conclude that the solutions of x are going to be negative 3 and positive 5. Now looking at part B, part D, simplifying is going to get us this, and then collecting like terms, you're going to get this. So this is going to give you a quadratic, but if you look at this quadratic, it can be further simplified simply by dividing through by 5. And if you divide through by 5, you're going to end up with x squared minus x minus 2. You may ignore this constant. And then if you prime factorize out this using your calculator, you're going to get two values of x. One is going to be x minus 1, that's why you're seeing this bracket of x plus 1. And also the other is going to be positive 2, that's why you're seeing this bracket of x minus 2. So either this bracket is equal to 0 or this bracket is equal to 0. So if this bracket is equal to 0, you make x the subject and you're going to get x as negative 1, and the other one is going to give you x as positive 2. And then from there, you conclude that the solutions are going to be x being equal to negative 1 and x being equal to negative or positive 2. Now with that, let's also first look at a word equation that may be interpreted as a quadratic equation. So majority of the numbers we're going to do are going to be in terms of word equations. So looking at this question, you are being told that a piece of wire of length 1 meter is cut into 2 parts, and each part is bent to form a square. Now, if the total area of the two squares that are going to be formed is 325 centimeters squared, you are required to find the perimeter of each of the squares. So, solution, we are going to start by saying that let one of the pieces of the wire to be of length x centimeters. Then the other piece is going to be of length 100 minus x centimeter. Now we are saying that 100 because 1 meter is the same as 100 centimeters. So we decided to convert meters into centimeters. So since we are having a wire of 1 meter, so we are assuming that we use 1 meter to form one square, and then we use the other remaining part to form another square. So if at all this is our total square, we assume that we are going to form the first square using x centimeters, and the other square is going to be formed using 100 minus x centimeters. Remember, the question is telling us to find the perimeter. So the square that is going to be formed using x centimeters, or the square that is going to be formed from this length, the first square which you are going to form using x centimeters, is going to remember that a square has equal sides, and all these sides are equal. So if at all they are equal, for me to get the length of each side, if at all I used a total of x centimeters, for me to use a total of each side, I'm going to divide the total centimeters that I used by 4. So that means that each and every side is going to be a quarter of x centimeters and a quarter of x centimeters. I hope you have understood that. Now let's look at also the other square. Now remember that they gave us the total area of the two squares. So if I'm to get the area of the first square, it's going to be side times side, which is the same as x over 4 times x over 4. And that means that the area of the first square is going to be equal to x squared divided by 16 centimeters squared, or else you don't forget the units. So from there, I go to the other square. So the other square, remember that, is going to be formed by a piece of length 100x minus 100 minus x centimeters. So since a square has equal sides and there are 4, for me to get length of each side, I have to get this measurement, and then I divide it by 4 for me to get the length of each side. So it means that this side is going to be 100x minus 100 minus x divided by 4, and also 100x minus 4. So I also get the area of this, and after that I combine, or I add these two areas, and then I equate them to the area, or to the total area which was given in the question. So doing that, getting the area of the second square is going to be side times side, and remember that each side is 100 minus x divided by 4. So if you get 100 minus x divided by 4, you multiply it with 100 minus x divided by 4. We multiply the denominator independently, we also multiply the numerator independently. So you're going to end up with, if you multiply the denominator independently, you are going to end up with 16. And then if you multiply the two brackets in the numerator, they are going to multiply each other. So that's why you're saying 100 minus x squared, because there are two brackets multiplying each other. Now in the question we are told that the total of the area of the two squares is 325 centimeters squared. That means that if you add area 1 and area 2, you must get a total of 325. So we get area 1 and then we add it to area 2. Now remember that here the LCM is going to be what? It's going to be 16. In the previous video, I told you that the first thing to do is to eliminate the denominator. When you have fractions, you multiply throughout by the LCM. So the LCM here is going to be 16. So 16 times this very digit is going to give you x squared. And also 16 times this very digit, the second digit, is going to give you the numerator only, which is brackets of 100 minus x squared. Now if you get 16 times 325, you're going to end up with 5,200. So with that, we simplify this bracket alone. Now I hope you can simplify this bracket alone according to the previous video. So you are going to use a shortcut for that. But we are going to teach this expansion in the next or in the second video of these quadratic equations. So in expanding this, it's going to be you square 100. You can either expand these brackets and you say that you're multiplying 100 minus x into another bracket of 100 minus x, and then you do it that way. You must end up with the same answer, but you're going to use a shortcut for this. So with this, we square the first value, and it's going to be 100 squared is going to be 10,000, and then we get 2 times the first value times the second value. So 2 times 100, you get 200, and then times negative x, you are going to get negative 200x. Then you also square the second value, which is negative x squared, and then you get positive x squared. But I say that you can use this interpretation if at all you have not yet learned expansions. We are going to learn expansions in the second video of these quadratic equations. So with that, we simplify by collecting like terms. So we are going to end up with, if you are told you add x squared and x squared, you get 2x squared, and then minus 200x. Now if you bring 5,200 this side and you subtract it from 10,000, you're going to remain with 4,800, and then you equate our equation to 0. So with this, you can see that we can easily prime factorize out, or we can easily divide throughout by 2. So if you prime factorize out 2 or you divide it, you're going to remain with a quadratic equation which is simplified as x squared minus 100x then plus 2,400. If you put this in the calculator, you're going to end up with two values of x. One is going to be positive 40 and the other one is going to be positive 60. So using the prime factorization method to show how those values can be got on paper, we simply reverse the signs and then you put them as factors. So it's going to be x minus 40 into bracket of x minus 60 to be equal to 0. I said that you can ignore this constant. So it's either going to be x minus 40 to be equal to 0, or it's going to be x minus 60 to be equal to 0. And you're going to end up with the solutions of x to be either 40 or 60, centimeters. So I make a conclusion for that. So with that, after getting those solutions, we are going to say that if at all x is equal to 40 centimeters, the square formed from the piece of wire AB has a perimeter of 40 centimeters, and the square formed from the piece of wire is going to have a perimeter of 60 centimeters. And if at all the value of x is equal to 60 centimeters, that means that the square formed from the piece of wire AB has a perimeter of 60 centimeters, and the square formed from the piece of wire BC has a perimeter of 40 centimeters. This is what we are talking about. Remember that to get the distance of one square formed by one square, we say that let the total length of formed by one square be bx, for example square A, and for that of square B be 100 minus x. So if at all you have got the value of x to be 40, this is going to be 100 minus x, which is going to be 60. So you're saying that if at all the perimeter of the first square is 40, then the perimeter of the second square is going to be 60. But if at all the value of x is 60, then the perimeter of the second square is going to be 40 centimeters. This is what this conclusion is all about. I hope you have understood that. Now proceeding, we are going to look at completing squares as the next method of solving quadratic equations. Now this is a very common asked idea that you need to understand properly, because there's a way it tricks a lot of students. So let's look at it. So simply completing squares is the process of adding, let's first wrap this. Completing squares is going to be the process of adding half of the coefficient of x term squared. So you simply have the coefficient of x and then you add it and you also subtract it. That's the process. For example, if you want to make x squared plus bx in terms of a perfect square, we are going to be halving the coefficient. For example, look at this. We are having x squared plus bx. So we simply get the coefficient of x. So if you look in this quadratic equation, the coefficient of x without any power is b. So we get it and we have it. So it's going to be b divided by 2. And then after having it, we square it. That's what you call completing squares. You get the coefficient of x, you have it, and then you square it. And that's what you get. So if at all you're having x squared plus bx, for you to complete squares, we are going to have the coefficient here, and then we add it here. Then after adding it, we try to simplify it. If you open this bracket, this square multiplies the numerator and also it multiplies the denominator, and then you end up with b squared divided by 4. And if you look at this expression, this expression was got as a result of saying x plus b over 2 squared. Like I said, we are going to teach you how to spell this, but simply after doing this, you get 3 terms, and then you take only the first value without a power, then plus the second value without a power, and then you're going to end up with your perfect square. But let's look at elaborative examples under that. So you can proceed by saying that the process of completing squares is going to be used to express a quadratic expression which is in the following format, in terms of this format, and this is how we are going to be setting the scenarios. We are going to provide you with a specific quadratic equation, or you may have calculated for it according to the items given, and then we tell you to express it in the form of this, where p and q are going to be constants. Now first, before completing squares, we first make sure that the coefficient of x squared, which is a, I hope you're seeing this quadratic equation up here, the coefficient of x squared must be equal to 1, and that's the first thing, as we are going to look at the examples. So for example, if you have a new quadratic equation in this form, x squared plus bx plus c, how are you going to complete squares for it? Now let's pay attention here. We say that to complete squares, we get the coefficient of x. So the coefficient of x here is positive b. It's positive b because the sign next to it is positive. So after that, we have the coefficient of x. So it's going to be b over 2. Now after having the coefficient, we square it. Then after squaring it, we add it to that quadratic equation. So simply your quadratic equation initially was x squared plus bx plus c. So what has changed about this equation is that we have added this, the square of the coefficient of x. We add it and then we subtract it. The reason why we add it and we subtract it is to create no change in the meaning of our equation. Assuming that I had x squared plus 2x, and I wanted to complete squares. Now we are going to look at the general examples in the next chapter or in the next slide. So looking at this, let's first pay attention here, or let's first pay attention to the basics. So what you're going to do is that you're going to have the coefficient of x and then you square it. After squaring it, you add it and then later you subtract it to create no change in the meaning of the given quadratic expression. Now after that, you bracket the first 3 terms. On bracketing the first 3 terms, we take the first value without its power, which is x, and then plus the second value without its power, which is positive b over 2, and then you put them under brackets and then you square them all at once. But remember that you bracket 3 values at once, then you simplify the rest. So the rest is going to be plus c. Then if you simplify this bracket, it's going to be minus, if you enter this square inside, it's going to be b squared divided by 4. So we simply brought this one here, which was a negative b squared divided by 4, then plus c, and that's how we complete squares. Now let's look at the live examples under this. So example 1, we have told you that express x squared plus 6x minus 1 in the form of this, and solve the equation that has been given. So So first thing first, we say that when you're completing squares, the coefficient of x squared must be positive 1. So after ensuring that, let's start by expressing this into that. So first we say that we are going to have the coefficient of x. If you look at this equation, the coefficient of x here is going to be 6. So having 6, we divide it by 2. That's what means that's what having means. And then after dividing it by 2, you're going to get positive 3. Then after getting 3, we square this 3. So we square the 3. After squaring the 3, you're going to get 9. So what you're going to do is that you come back to this very equation. Immediately after 6x, you add 9, and then you bring back your negative 1, and then you subtract 9. So we add 9, and then we subtract 9, which is the coefficient, which is the squared after coefficient of x. I hope you have understood that. Like I said, if you're not understanding, or if you need any clarification, make sure that you raise your issue in the comment section, and if you're understanding, you like the video, so that I can get your feedback. So here, let's review this a little bit. The coefficient of x is positive 6. We have the coefficient of x, and then you're going to get 3, and then we square it, you're going to get 9. So after doing that, you write the first two values of your quadratic equation, and then you add that value that you have squared. And then you write the last value, which is negative 1, and then you subtract this very value, which you have got. That's what completing squares means. So after understanding that, we bracket the first three, we bracket the first three digits. So under this, we ignore the middle digit, and then we take the first digit without its square. Or we take the square root of the first digit. So square root of x squared is x. And also we take the square root of the third digit. You ignore the second digit. You leave it out, because this bracket is the same as this expansion, as we are going to look at it in the next video. So it's going to be x plus square root of the last digit is 3. So it's going to be bracket of x plus 3 squared raised to power, if you're having negative 1 minus 9, you're going to end up with negative 10. So I'm going to say that. Now remember that this equation, that means that this equation can be written in this format. So we are told that hence solve this equation. So they are telling us that the hence part, we are supposed to solve that equation when it is being equated to 0. So we simply say that instead of writing this very equation, we simply substitute it with what we have simplified. Since it's the hence part means that you continue from where you stopped. So our equation, x squared plus 6x minus 1 is the same as square bracket of x plus 3 minus 10 being equal to 0. So if you look at this, we make our square bracket the subject simply by taking 10 or negative 10 this side. So you're going to end up with square bracket of x plus 3 to be equal to positive 10. So for me to get rid of this square on our bracket, I have to find the square root on both sides. And they say that when you're finding square root on both sides, or when you're finding square root, your value or your answer must be positive or negative, and it must be on your right hand side. So positive or negative, so x plus 3, if you find square root on both sides, this square is going to go away and then remain with x plus 3 being equal to positive or negative root of 10. So if you make x the subject, you simply take positive 3 this side across the equal sign. It's going to become negative 3 plus or minus root of 10. So if you put this in the calculator, first you write negative 3. First you write negative 3 plus root of 10. Because you're having positive or negative, hope you are seeing these symbols. You're having two options. You either take negative 3 plus root of 10, or you take 3 minus root of 10. That's what it means. So you're going to get, when you're having negative 3 plus root of 10, and when you're also having negative 3 minus root of 10. So the first value that you're going to get from this is going to be 0.1623, and the other value is going to be negative 6.1623. If you look at these solutions, all the answers are rounded to 4 decimal places, because we say that the actualist mark or the actualist mark in pure mathematics is going to be got when the final answer, if it is in terms of decimal places, it is to a minimum of 4 decimal places. Below that, you're going to be denied the actualist mark. So looking at question 2 or example 2, we are supposed to use the method of completing squares to solve this quadratic equation. Now if you look at this quadratic equation, our coefficient of x is -3. It's negative 3. So if you look at this, doing the completing squares, we are going to get -3, then we have it, then after that we square it, and that's going to be what we add and what we subtract. So let's look at its solution. So the other one, I left it so that you can do it as an assignment. If you get the answer, you try to submit it individually. Now looking at example 2. Now example 2, we are having a scenario whereby our coefficient or our value of x squared has got a coefficient. Remember that before you could start completing squares, the coefficient of x squared must be +1. So we must complete squares for the quadratic equation 2x squared plus 8x plus 5. And when after completing squares, our expression must be in this format. And then later we say the values of AP and Q. Now looking at the solution, since before we complete squares, our coefficient of x must be +1, we are supposed to do what we call prime factorization. And that's the only way we can make the coefficient of x squared to be +1. Now some of you mistaken prime factorization with division. You cannot divide through by 2 if at all your quadratic equation has no equal sign. If it had an equal sign, for example, if it was equal to 0, then there you are free to divide through by 2. But if at all the quadratic equation is not equal to 0, we do what you call prime factorization. So it's going to be 2 into bracket of x squared plus 4x, then plus 5/2. Then after that, if you look at what is in the bracket, that means that our value of x has really got a coefficient of +1. So since it has a coefficient of +1, we can proceed to the steps of completing squares. So in our completing squares, we identify the coefficient of x. So in this case, our coefficient of x is +4. So we get 4, and then we divide it, or we have it. So if you have 4, what do you get? You're going to get +2. Then we square what we have got, or we square the result. And if you square +2, you're going to get 4. And now this is what we add and we subtract. So write the first two values, you add your 4, and then you write the last digit, which was 5/2, and then we subtract our 4. So we bracket these 3 terms, the first 3 terms, and then we ignore the second digit. We take the square of the first digit, which is going to be x, and then we take the square of the third digit. Square root of 2 is square root of 4 is going to be 2. Square root of x squared is going to be x, and then we put them in the single bracket, and then we square that bracket, and then we simplify the rest. So simplifying the rest is going to mean that you're going to have +5/2 minus 4, and you're going to, if you put everything in the calculator properly, you're going to end up with -3/2. Now ensure that all these ones you retain your brackets. Majority of you make mistakes from here. You must make sure that you retain your brackets. Now after that, we open up these brackets simply by multiplying the first digit and also the second digit by 2. So when you open this bracket, it's going to be 2 bracket square bracket of x plus 2. And then if you multiply 2 by -3/2, you're going to end up with -3, because the 2 are going to cross each other. I hope you have seen that. So that's the final answer we are going to end up with. Now since we have already expressed our value in terms of the required expression in the question, though in the question it's plus 2, yet here our last value is -3. This scares some of you a lot of times, but here you don't care. This one is the same as saying plus -3. So it means that your value of 2 is going to be equal to -3, your value of p is going to be equal to 2, and then your value of a, which was the coefficient of your bracket, is going to be equal to positive 2. Now, looking at this question of the similar kind, we are going to express this. We are going to complete squares for this. Now, you can first pause the video and first try to complete the squares for this, and then we handle the nth part together. First pause the video and then handle this alone and try to see whether you're going to come up with my solution in this format. So 5 seconds for you to pause the video and try it out. Now looking at the solution, so still this one is in the same format like the previous one. So since the coefficient of x squared is not positive 1, we first have to make it positive 1 by prime factorization. And if you do that, you're going to have 3 into bracket of x squared plus 5x. Then when you're prime factorizing, 3 has to divide each of these elements. So 3 divided by x squared, you get x squared. 3 divided by 15, you get 5x. And then 3 divided by positive 20, you get positive 20 divided by 3. Then after showing that the coefficient of x squared is positive 1, you get the coefficient of x in the equation. So the coefficient of x in the equation is positive 5. And then that's what we have. So we have positive 5, and then after that, we square our halved coefficient. And then you end up with this bracket. So this is what you're going to add, and it's the same thing what you're going to subtract. So you write the first two values, and then you add it, you write the last value, and then you subtract it. Then you bracket the first 3 values. You ignore the second digit, and then you add the square of x squared, which is x, and you add also the square of 5 over 2, which is going to be 5 over 2. If you put this in the square root, the squares are going to go away. So if you add it to x, it's going to be plus 5 over 2. Everything raised to power, everything you square it after ignoring the second digit. So you simplify others. So first we have to open up these brackets. If this square enters, it has to square both the numerator and the denominator. So it's going to be 20 over 3 minus 25 over 3. So if you put this into your calculator, you're going to end up with positive 5 over 12. So after that, after showing that what is inside the bracket is simplified, we can open up the brackets. So 3 is going to multiply the first bracket, and also 3 is going to multiply the second digit. So 3 times the first bracket, you're going to get this. 3 times 5 over plus 3 times 5 over 12. The 3 is going to cross, and then it's going to divide 12, and then remain with 4. So that's why down here, you're seeing that you're having 5 over 4. So our final answer is in terms of 3 into square bracket of x plus 5, and then plus 5 over 4. Now remember that you're supposed also to solve that equation. So you are told that, so first you have to write our equation and you equate it to 0. But remember that this one is the same as this. So where this equation is, we are going to substitute it with our quadratic equation, which we have completed squares for, and then we try to solve it up. Now on trying to solve that up, we are going to take 5 over 4 the other side, and if it crosses the brackets, the equal sign is going to become negative 5 over 4. Now here, after that, we divide through by 3. If you divide through by 3, it's going to be times 1 over 3 this side. Or this 1 over 3 multiplies negative 5 over 4, that's why you end up with this answer, 5 over 12. So for us to get rid of this square on this bracket, we have to get square root on both sides. When you are getting square root, it has to be positive or negative. But here, we cannot get a square root of a negative value in pure mathematics unless it's complex numbers. So what you do here, you simply say that the value of x is not real, just like the question was saying that show that it's not real. So we are going to make a conclusion that since we can't get the square root of this negative 5 over 12 is not real, then the equation has no real roots because you can't find the actual value of x. Simply because you can't proceed because we don't have the square root of a negative value. Now let's look at another question. Now for another question, you're going to be asking you how to find minimum and maximum value of the given functions. So assuming also that's under completing squares, assuming that you're having a function of x to be equal to 13 plus 6x, then plus 3x squared. State the value of x for which the minimum occurs and also state the minimum value. So what you have to do is to write our solution, our question, and then we rearrange according to powers of x. So according to powers of x, 3x squared is going to come first, 6x is going to come second, and then 13 is going to come last. Then after doing that, we ensure that the coefficient of x squared is positive 1, and we do that by prime factorization. So we're going to remain with x squared into bracket of, if you divide this by 3, it's going to get you 2x. And if you divide 13 by 3, you're going to get this as the last value. Now from here, we complete squares. So we get the coefficient of x from this step. So from this step, the coefficient of x is 2. So first we have it by 2, and then it gives us positive 1. Then after that, we square what we have got, or our coefficient, and you're going to get 1. Then later, we complete squares. So you write the first two values, then you add the squared coefficient. Then you write the third value, and then you subtract the squared coefficient, just like we have been doing. Now let's try to simplify this. So after that, so just like we said, that you get the square of the first value, square root of the first value, then plus the square root of the third value by ignoring the second value, and then you put them in the bracket and then you square it. Then you simplify the other remaining terms, and then you're going to remain with positive 10 over 3. So if you bring back the 3, if you open up brackets, 3 multiplies the first digit or the first bracket, you're going to end up with this. And also 3 multiplies 10 over 3, you're going to end up with positive 10. So you're saying that the minimum value of f into x is going to be 10. Now how are you going to get the minimum value? The minimum and maximum value is going to be that value that is not attached to your bracket. Remember that always is going to be the value that is not attached to your bracket. Whichever they have asked, if they have asked you the maximum value, it's also going to be that value which is not attached to the bracket. So the value which is not attached to the bracket here is going to be 10. It is positive 10. Therefore, the minimum value is positive 10, and it's going to occur. So the value of x at which this occurs, you simply get your bracket, your squared bracket, and then you equate it to 0, and then you make x the subject. So minimum value of f of x is 10. So the value of x at which it occurs, we get our square bracket and we equate it to 0. Then later we make x the subject. So x, if you find square root on both sides, you're going to have x plus 1 to be equal to 0. And if you take 1 the other side, you're going to end up with x being equal to negative 1. So we can make a conclusion that minimum value is going to be positive 10, and then it's going to occur at a value of x which is equal to negative 1. Now the next question has been given as a polynomial of f of x to be equal to 1 minus 6x minus x squared, and then say the value of x at which it occurs. Here we are finding the greatest value. So before we start, the first things first, we need to find we need to first make the value of x squared to be positive 1, and we are going to do that simply by prime factorizing out a negative on x squared. And if you do that, now this one was done quite in a bit tricky way, but you can do it in a basic format. So let me try to elaborate it here. With that, we are going to first make the coefficient of x squared to be positive 1. So if you make the coefficient of negative x to be positive 1, you're going to prime factorize out a negative. So you're going to remain with, if you prime factorize out a negative, you're going to remain with x squared plus 6x and then minus 1. So to do, we have the coefficient of this. So having the coefficient of this is going to give you 3. And after that, we square it. Having it is going to give you 3, and after that you square it, you're going to end up with 9. So when you're completing squares, it's going to be negative bracket of, so it's going to be x squared plus, you write the first two digits, x squared plus 6x, then plus 9, then you write the last digit minus 1, then minus 9. So we bracket the first 3 digits and then we finish squares for that. So it's going to be negative bracket of, so this is going to be bracket of x plus 3 being squared. X plus 3 being squared. Then if you simplify this, it's going to be negative 1 minus 9 to get you negative 10. Then after that, we are going to open up the brackets. If you open up the brackets, this negative multiplies this bracket here, and then it also multiplies this negative 10, and then you get positive 10. So that's why we are saying that, that's why you're seeing this equation here. You have to get the same values. I hope you have understood that. So you're saying that since the value of square bracket of 3 plus x is the square of a real number, it cannot be negative. So it is 0 when x is equal to 3, otherwise positive. Now here we just made the conclusion that the greatest value of the function is going to be 10, and it's going to occur at a value of x equals negative 3. You may currently ignore this for the beginning or for the start. We are going to look at it more in details when we look at advanced concepts. So first, to get the value, we said that to get the greatest value is going to be the value which is not attached to the bracket, and here in our equation is positive 10. And then to get the value at which x occurs, you simply get your quadratic and then equate it to 0. And if you make x the subject here, you're going to end up with x being equal to negative 3. So that's why you're seeing this conclusion that the greatest value of the function is positive 10, and it's occurring at x is equal to negative 3. And that was the solution required. Now, since we have looked at a bunch of examples, let's go through this one quickly. So you're showing that this quadratic equation cannot be negative, and you're also finding its least value. So you can find great or least values simply by completing squares. So when you complete squares for this equation, you have the coefficient of x, you add it, and then you subtract it, you bracket the first 3 values, you add the square of the first and the second, you're going to end up with this. And then plus, you simplify the rest. 3 minus 25 over 9, you're going to end up with 2 over 9. Opening up brackets, 3 multiplies this first bracket, it also multiplies the second digit, and then you end up with this expression. So here to get the value, the least value is going to be the value which is not attached to the bracket, which is 2 over 3. And to get the value of x at which it occurs, it occurs, you simply get your square bracket and equate it to 0. So it's going to be negative 5 over 3. Now we are saying that to show that it cannot be negative, we are saying that since the square bracket of this is a square, the least value taken is going to be 0, so that it cannot be 0 and it cannot be a negative. We are having a square, any number which is raised to a square. For example, if you're having positive or negative v and you have to raise it to a square, there is no negative number that survives under a square. So that's why we are giving this conclusion that since you're having a bracket of a square, there is no negative digit which is going to be present in our final answer. Now let's also find the least value if at all you are being given a reciprocal function. So when you're given a reciprocal function, they remain the same procedure. It's just that you're handling a fraction this time. So you have to make the coefficient of x squared positive 1, and then we complete squares by having the coefficient of x and then adding it and subtracting it. Then later you bracket the first 3 and then you get your first bracket and the last bracket. Then later you open up this bracket by multiplying this negative by the first digit and also by the second digit, and then you end up with this answer. So you're saying that the least value of our function is going to be a third, simply because we are having 1 over 3, and also it's going to occur at a value of x. You simply get your square bracket and then equate it to 0. That's how you get the value of x at which the minimum value occurs. And your final answer is going to be this value to be a third, and then occurring at the value of x when you equate the square bracket to 0, it's going to be equal to negative 1. Now that was it about completing squares. Now let's cross to quadratic formula. Now the quadratic formula is also called the Bordoza method. and it's the most commonly used method at A level. So you're going to say that if at all you're given a quadratic equation in this format, ax squared plus bx plus c. Now notice that this formula is available in your logbooks. So but as you proceed in your journey, you are going to reach a time whereby it's next to you, because it's the most commonly used formula in A levels. So I'd either advise to understand it or cram it. So where a, b, and c are going to be constants, but they're not going to be equal to 0. So you're going to say that if at all, for example, for you to use a quadratic equation and you're having your unknowns in terms of x, so here it's not a must that this quadratic equation is going to be equal to x. If at all the unknown is in terms of x, it's going to be x equals to this function. If at all the unknown is m, it's going to be m to be equal to this function. So it's going to be negative b plus or minus b squared minus 4ac divided by 2a. So let's use that in given examples. So solve the following equations. Now if you look at these equations, this quadratic, we say that your quadratic equation must be equal to 0 for you to use this formula. So if you look at part A, our quadratic is not equal to 0. So to do that, we have to take 7 on the left hand side. And if you take 7 on the left hand side, we are going to end up with a quadratic equation. So after getting the quadratic equation, you identify your A. Your A is always the coefficient of x squared. You identify your b, which is always the coefficient of x. So here the coefficient of x is negative 7. And then you also identify your c, which is always the value without any coefficient of x. And this case is positive 11. So my a is equal to positive 1, my b is equal to negative 7, and then my c is equal to positive 11. So after that, we substitute it into a quadratic formula. I've said that you need to cram or understand it or use your logbook when you're in your examination to memorize it. But it must be second to you. So you need to use it in a lot of practice questions. So using the quadratic formula or using the bulldozer formula, where there is b, we are going to substitute it with our value. So the bulldozer formula says that it's negative b plus or minus b squared minus 4ac divided by 2a. Now here we mark what you call substitutions. You have to substitute without calculating anything in the head. So some people you may see where you see negative b and you're having your negative 7, you may just write positive 7 in your answer. Now this one gets it wrong. We have to see the substitution that you're making, that you're substituting for b, and you're leaving the negative there to be present as presented in the bulldozer formula. So where there is b in your quadratic formula, we substitute it with our value, which is the coefficient of x. Where there is b, you simply do substitutions, and then later you put everything in the calculator, and then you compute everything at once. Now here, the purpose of using the quadratic formula is because it's very simple. All you need to do is to simply show the substitution in the bulldozer formula. Now after showing the substitution in the bulldozer formula, get me a property. All you have to do is to show this on your paper or in your examination sheet. After making sure that you have done correct substitutions, you get this quadratic equation that you're solving, x squared minus 7x plus 11, and then you put it in your calculator. So for the bulldozer is to help you simplify and get rid of the steps that you have been seeing about in the previous methods. For it, you just have to make the substitution so that you can get the bonus, the 2 marks for that, for making the substitutions, for making appropriate substitutions and for appropriate use of the bulldozer method. Then the answer methods are going to be, or the answer marks are going to be on the final answers. So after you substituting, making proper and appropriate substitution in the bulldozer method, do not try to calculate out anything using this method, because majority of you make mistakes from there. So instead, you just pick your calculator. After making substitutions, you just pick your calculator and then you substitute in these values into your calculator. Then later, after writing this bulldozer formula, you just come and you give me what your calculator has given you. So your calculator, after typing this, is going to give you 2 values of x. So one of them is going to be 4.618 and the other one is going to be 2.382. And that's what I need. And that's the good thing about the bulldozer method. You don't have to simplify it. You just write it and then put your quadratic in the calculator and then you give me the final answer. But we need to see you writing this bulldozer method for you to get the substitution marks, which are going to be 2. Then later you put this quadratic into your calculator and just give me the final values of x. Do not simplify the quadratic equation or the quadratic formula. So the same idea here. First, our a is equal to 2, our b is equal to negative 11, and our c is equal to positive 12. So substituting into the quadratic formula, you're going to get this. After doing the substitution, do not solve this quadratic expression. Just get your calculator and substitute in this equation. And then later there, you just give me the 2 values of x. So you simply tell me that x is going to be equal to 4, or x is going to be equal to 1.5. Now here you're being given solvable questions that you're going to try out under that. So you try out part A and you also try out part B. Start by identifying the values of A, B, and C, and then you substitute them into the bulldozer method or the quadratic method. I said that this one should be your second, should be at your fingertips. So you find a way of memorizing it, but it's also available in the logbooks. You should purchase logbooks and you enter with them in the examination halls. It's acceptable. So proceeding, we are going to be looking at discriminants of a quadratic equation. Now if you look at your quadratic formula properly, you have seen that under square root we are having what you call b squared minus 4ac. So this is what we call the discriminant. What is inside that square bracket is what we call the discriminant, and it's written as b squared minus 4ac. Now you may ask, what's the purpose of the discriminant? The discriminant is going to help us identify whether we are having repeated roots, or whether we are having unreal roots, or whether we are having equal roots or real roots. So you're saying that the discriminant d is going to be defined by b squared minus 4ac, and it's called the discriminant of the quadratic equation, which is the expression always under the root under the quadratic equation, or what is also called by the bulldozer method. And you have said that that method is available in your logbooks. So try to purchase a logbook and have it or own it as a senior 5 member. So proceeding, I say that the type of root which arises from a quadratic equation depends on the value of the discriminant. So if at all you have got your discriminant to be equal to 0, then the roots of that equation are going to be known as Rx, or what's mainly used are going to be called repeated or equal roots. If at all you have substituted for your value of b squared minus 4ac. If at all you have substituted for the value of b, and you have substituted for the value of a, and you have substituted for the value of c, and you get your final answer to be equal to 0, we assume that that quadratic equation that you are solving has equal or repeated roots. But now, if at all you have got your discriminant to be 1 and above, greater or equal to 1, that's why we are saying that if at all your discriminant is greater than 0, that means that that quadratic equation you're solving has unequal and distinct roots. So when you're asking you, we may tell you that to show that the quadratic expression you have got either has equal or repeated roots, or it has unequal or distinct roots. And if at all your discriminant is below 0, that means that you have got a negative answer after substitution into your formula. That means that the quadratic equation you're trying to solve has no real roots, or whichever equation you're dealing with has no real roots, because you can't get a negative. Because if at all you solve your discriminants and you have got a negative, for example, you have got a negative 2, remember that in your quadratic formula it's going to be under root, and we say that we don't have square root of a negative number. So that's why we are saying that if at all you get a negative to be below 0, then we assume that that quadratic equation you're solving is not going to have any real roots, because we won't get anything in the calculator. So now we are going to do a simple example about those roots according to the conditions that we have talked about. So simply we are given quadratic equations. A, B, and C. So our aim here is to identify the value of A, the value of B, and the value of C. And we have said that the value of A is always the coefficient of x squared. The value of B is always the coefficient of x. So here is -5. Here is -28. Here is -7. And the value of C is always the value that has no coefficient of x. So we're going to say solution. So for us to identify the nature of roots contained by a given quadratic equation, we have to substitute the values of A, B, and C into a discriminant, which is always that formula under the root of a quadratic equation. So for part A, our discriminant is the same as b squared minus 4ac. So we say that if we get a value which is equal to 0, the equation has equal roots or repeated roots. If we get a value which is less than 0, the equation has no real roots. And if we get a value which is greater than 0, we assume that that equation has real and distinct roots. So if you look at part A, my A value is 3, my B value is -5, and my C value is 2. So substituting into the formula of the discriminant, I'm going to have -5 squared, then -4 into 3 into 2. So if you put everything in the calculator, you're going to end up with 1. So the value of the discriminant I've got in comparison to 0, you see that 1 is greater than 0. So that means that my discriminant is greater than 0. So that means that this equation has two real and distinct roots. So that's how you identify whether an equation has real, equal, or and distinct roots, or has no real roots. So looking at part B, we repeat the same procedure. A is 4, B is -28, and C is 49. Substituting into the discriminant formula, you're going to get 0. And we said that when you get 0, that means that that equation has equal or repeated roots. Now for part C, we do the same thing. We do the substitution. So for part C, you have seen that we have got -11. So that means that for part C, our discriminant is less than 0. And we said that if at all the discriminant is less than 0, then that means that that quadratic equation we are trying to deal with, that means that it has no real or it has no distinct roots. So that's why we made a conclusion that the quadratic equation being solved has no real roots. Now we are going to do the same concept, or we are going to elaborate the same concept onto this other item. So I told you that find the values of the constant k given the equation this. So if you look here, just like the previous one, here is just that we're having constants. The value of A is always going to be the coefficient of x squared. The value of B is going to be the coefficient of x. So if you look in this equation, the coefficient of A is equal to 5k plus 1, which is this. Our B is equal to -8k because it's the coefficient of x. And then our C, which is the value without any attachment to the x value, is 3k. That's why you're seeing it here. So we get our discriminant equation, and then we have to substitute for everything under that. And then we see whether we get a negative answer or a positive answer. Now here, we are being told that it has a repeated root. Now remember that for the condition for repeated roots is that the discriminant must be equal to 0. That's when your quadratic equation has a repeated root. So what you're going to do, you're going to use the discriminant formula, but our d this time must be 0. And then we get the unknown constant, which is k. So making appropriate substitutions, where there's b, you substitute for b, where there's a, you substitute for a, and where there's c, you substitute for c. So opening up those brackets, you're going to end up 64k squared minus 12k into 5k plus 1. We have got this 12k by multiplying this 4 by and 3k. That's why you end up with this. But remember that if you open up these brackets, it's going to be 12k squared, 12k times 5k, and then you're going to get 60k. So 60k squared, you're going to get 60k squared. 60k squared minus 64k squared, you're going to get 4k squared minus 12k. But remember that they told us that this quadratic equation has repeated roots, and the condition for repeated roots is that the discriminant must be equal to 0. So that's why we got this value and then we equated it to 0. Now you are seeing that here we are having two unknowns. We say that we don't divide through by unknowns in pure mathematics. So what we do is that we simply prime factorize out the common factor. So the common factor here was k in the first place, but also 4 can be prime factorized out from both of them. So you remain with 4k into bracket of k minus 3. So it's either k is equal to 0 or k minus 3 is equal to 0. So that's why you're having k is equal to 0 and also k being equal to positive 3. And therefore the required values of k is either going to be 0 or it's going to be positive 3. And that was it for this video. So what you're going to do, we are going to look at an assessment to assert or to test your understanding. So you're going to pause the video and then you try to take down the following questions. All of them, we have looked at them as different concepts under this video. I hope you have understood fully each and everything that was discussed. And try to share the video to a colleague who has not seen it yet so that you can be on the same platform as a team. So you pause the video and you try to take down the questions. So that brings us to the end of this video. We meet in the next video that is going to be finalizing quadratic equations. Share the video to your colleagues and make sure that everyone is with you. We meet next time.